Hi guys, I want to make a quick video about 3.4, which is a really important section about z-scores, identifying outliers. So let's jump right in here, okay? Um, so there's a formula for z-score, and I know, right, jumping right in, um, but you do have an idea of this actually, right? So what we're talking about z-score is a bell curve. Now, in a normal standard distribution, we have the mean is 0 and a standard deviation is 1 or -1 and then 2, right? So what we do is, if you saw the problem with the IQ, is we think of the same exact curve, but now we're given, right? We're given a mean and we're given a standard deviation. So instead of thinking of the mean like we do in the normal as 0, we think of it as 69.6 in this one. And instead of thinking of the standard deviation as 1, we think of it as 3.1 in both directions. Okay, so you just add or subtract 3.1, so this would be 66.5, right? Sorry, let me adding 3.1 to 69.6 would give 72.7. So, in the first question, we're asked find the z-score corresponding to someone 75 inches tall for a male or 70 inches for a female. So over here, I can't see this because mine's blocked. We have the female information of the mean is 64.3 and standard deviation is 3.9. So if we were doing this by hand, the formula for z-score is z equals x minus the mean divided by the standard deviation. Okay. So for instance, in the normal one, right, the mean is 0, standard deviation is 1. So if we were one standard deviation, it would be a z-score of 1, which is equal to the standard deviation. But when we are given the mean and the standard deviation, we don't assume 1 and 0. We write it like this: n of the mean, comma, standard deviation. So this is the one they're asking about for the men. N stands for normal. The first number is the mean. The second is the standard deviation. Okay. So if we want to calculate the z-score of a 75-inch tall male, we do z equals the x value. This is what we're asked about. So 75 is x. The mean we're given as 69.6, and you divide by the standard deviation. So if you calculate that with a calculator, which again, this is stuff I would ask on the test to do by hand, but I'll show you how to do it with statcrunch too. 75 minus 69.6 is 5.4. Divide that by 3.1, and you get z is 1.74 for this person. In other words, if you imagine two normal curves, the person's z-score with 1.74, this is the middle, that's somewhere over here. Okay, that's all it's saying. This is z 1.74 or approximately 1.74 standard deviations from mean. For the female, same exact formula, z equals the x value, which is 75, minus the mean for female, 64.3, divided by the standard deviation for females, 3.9. So if we do that, we get 75 minus 64.3, which is 10.7, divided by 3.9, and that's a z-score of 2.74. Okay, so this question is just asking who is the larger relative to z-score, and it's clearly the female. Okay. Um, okay. So how would we do this in statcrunch? Let's try it. Let me clear this. So we had 2.74 for female. That's the z-score. And the male z-score was, I think, 1.7. Do it again. 70 minus the mean divide. Oop, 75 minus the mean. So I think I used the wrong mean. Let me try this again. So 75 minus the mean for males was 16.6. I think we got that one right. So that was 1.74. I think I did the female wrong because I used the male mean. So let's try that again. So the female mean is 70 inches. Oh, sorry, 64.3. So 70 minus 64.3 divided by the standard deviation, 3.9. So the female z-score was not that. It was 1.46. Okay, so I used the wrong one, but that's okay. Let me show you. Again, that's sort of the pitfalls of doing things by hand. Let's try this in statcrunch. Okay. So essentially when we're in these type of things with z-score, we're talking about a normal distribution. So we go to stat, uh, calculators, normal. Okay, so here's what we do. Let's say we want to calculate the z-score for a male. We enter, let's see, mean is 75, standard deviation 3.1. We're asked the probability that the person is, sorry, the mean is 69.6. I keep confusing this. Okay. Probability that the person is less than. So this is, it's a little trick here, but watch this. 75. That's going to give us the z-score. Okay, so what that does is this little mark where the red stops, that's associated with the z-score. The red's given by an area. So a short little trick to do is copy this, Control C, reset the mean to the normal mean of 0 and 1. And then you can paste it back. And then compute what this is. And this is going to be your z-score, 1.74. Okay. So that's a sneaky little way to get the z-score without having to do it by hand. Let's go to the next one. These are all not too bad, right? So they're asking Ted's z-score, right? All that's saying is what's the mean? What's the standard deviation? We're given that. The mean is 185.07. We don't round, we just put the whole thing. Standard deviation is 0.313. Nope, we're at 10. And Ted finished with a 184.49. So 184.49. Okay, when you're getting z-scores, always leave this as less than or equal to. Area to the left. So this area right here is what we want. So if we change this to 0 and 1, oh, that's why you don't delete it. Let me reset that. So you have to copy it. I guess I was right. 185.07. Compute. So copy this, Control C. Then reset this to 0, 1. Okay. So what we're doing is we're saying the area that was associated with his score, what would that be if you translated it or mapped it to the regular normal? And that would be a z-score of negative 1.85. Okay. So put that. And then for Amber, you do the same thing. She just had a different mean and standard deviation. So 111.6. Standard deviation 0.128. And then her time was 111.39. Hit compute. Copy this. Reset this to 0 and 1. That. Paste this. And calculate the z-score. It's negative 1.64. Okay. Going on. So the standard deviation and a mean again. Um, so how would we do this one? Okay. What is the minimum score that student must make on the test to be accepted? So you have to place 2.5 standard deviations, right? So one way to do that is Shit, let me close this. This open. So in statcrunch, let's do stat, normal, calculator's normal. 2.5 standard deviation. So that doesn't mean that standard deviation is 2.5. Okay, we just set this to 2.5, right? In fact, we can set it, they have to score above that, so let's flip this to greater. So this is what the problem's saying. If we left the mean as 0 and 1. So we want to copy this area. Can't see it because this stupid thing's blocking. There we go. Control C. And then we want to enter our mean and our standard deviation. And then paste this. And then we compute the score that they would need. So they would need to score 359.999, so a 360. Okay. So essentially what we're doing is we're going back and forth between the same curve, but when we switch the standard deviation from 0 and 1 to what we're given, the area still maps between them. Okay. So we put 360 for that. So you kind of can see that these all sort of follow the same pattern. Um, one thing you have to be wary of is sometimes it'll ask for between, so you have to click this. Um, or sometimes you have to flip this to greater than, depending on what it says. So you have to read them carefully. So let's jump into another one. Okay. So now we have data. Okay, explain the meaning. Well, there's not much to do here. Okay, so we don't really have to really go to the normal calculator in statcrunch. So it's asking us to explain the meaning of the 10th percentile. The head circumferences of 3 to 5 month males is only 41. Okay, 10th percentile. Okay, so percentiles we can think of as related to the area under the curve, right? So 90%, let's read each one. 90% of 3 to 5 months olds have a head circumference that is 41 centimeters or less. 10% of 3 months old, 41 centimeters or less. 10% of males have a head circumference. So that one seems wrong, right? It's 3 to 5 month old males, so they can't be safe. 10% of 3.5 month old males have a head circumference of 41 centimeters or more. So which could it be? Okay, it's not actually the easiest question, but let's see. So you can see these are going up. So the 10th percentile is down here. And why is this standing height? It's asking about head size. That seems weird. Let's open this, see what's going on. Why are they talking about standing height and head circumference? Probably it's two different data sets. No. Very strange. Um, okay, so waist circumference. Okay, so I don't think, yeah, this data is not for this question, it's for part C. So we're really just limited to what we're given here. So, but 10th percentile is 10% of it. So think of it this way. It's like, this is the 10th percentile right here. Maybe this is the 90. This is the 50th percentile. Okay, so um it's probably B, right? Because 10 is way to the left. And we always go to the left. So all right. And crimes. All right. So they're introducing something called quartile. And I think the next section is going to focus more on that, but let's talk about that. So we have something called interquartile range and quartiles. So Q1 means this, right? So we have our whole thing of data. It's ordered least to greatest. Okay. So the first 25% of the data up to this point called Q1 is right there. Then we have Q2, which is the median. Then we have Q3, which is, that. Okay, so let's talk about this. Q2 is the median. We expect 50% of data to fall between Q1 and Q3. Okay. 25% to fall below Q1, 25% to fall above Q3. Okay. We usually do this by taking medians. Now, this is not the best example because we don't have the data. All right. But essentially, um, it's asking 75%, 25%. So it's, this would be 75% or less to be 75% more than Q1 and so on. So that's really all this question is asking about. Uh, cool. So this is not too difficult. This one, given a test score of 130, that's right here. What percent does that fall to right there? Okay. I don't want to do these too much because I think you guys can figure these out. Okay. So for this, we can open the data in statcrunch. Okay. Give it a second to load. Okay, so we have our data. And so what an upper fence is, it's a cutoff point for when things would be considered an outlier. And that's given by this. Q3, well, Q3 plus 1.5 times interquartile range. Okay, should be times. So that's the upper fence. So anything above that is an outlier. So how do we calculate Q3? Q3 is given by 3, so the formula n plus 1 over 4. Okay, that's the term, right? So whatever term that is, that's the one that we use as Q3 boundary. So let's say for this, how many data points do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. This is hard to do by hand because it's not ordered. But we use that formula. We have 20 data points. So Q3 for this, the Q3 point is 3 times 20 plus 1, so 21 divided by 4, which is let's see, 3 times 21, 63 divided by 4 is 15.75. So that tells us that the Q3 point is between the 15th and 16th term. Okay. And you find the midpoint between those two. So, but we can't really do it here, right? We need our data organized. So imagine we had the data organized from least to greatest. We'd find the 15th term from here and the 16th, and then find the midpoint of that. Now, statcrunch will do it for us. Watch how quickly. Do stat, calculator, summary stats, columns. We just have to add these last few bits. We need IQR as well. Let's select that. So it's going to calculate if you see Q1 and Q3 for us. Oh, yeah, now I selected this. So Q3 is 489.5, which is the midpoint between 2 points. So then once we know that, we come back here. We also have IQR, but this number, guys, IQR, is just calculated from Q3 minus Q1. I'll write Q1's formula in a second. But anyways, we do 489.5 plus 1.5 times the IQR, which is 107. So that means that anything above that is an outlier. Okay. And formula for Q1 is a little similar to that. Let me get rid of all this stuff. It's crazy here. It's given by it's almost identical to the Q3 formula. So Q1 is n plus 1 divided by 4, and it's that term. If it's between two terms, like it's decimal, take the midpoint. So for this, it'd be 21 divided by 4, which is 5.25. So it's the midpoint between the fifth and sixth term. Okay. And this, they already calculated for us 32.5. And the formula for lower fence to determine outliers as well is Q1 minus 1.5 times interquartile range. Okay. So that's the calculation. And that's pretty much it, guys. So for that, the cutoff point for the upper fence was Q3, come on, plus 1.5 times IQR. So simply enter this data into statcrunch, get Q3, get the IQR, calculate this, and that's your cutoff point. Okay. All right, let's look at this one real quick. So if you want to find z-scores for these, it's probably the last one I do. I'm gonna do this real quick. Moving these up. So first thing we need to do is calculate the mean and standard deviation of these. So we go to summary stats, columns. Now they want us to treat it as a population. Okay, so we need to add the unadjusted standard deviation. Hit calculate. Okay, so we take that standard deviation right here, 7.95, rounded to 2 decimal. Maybe we go 3, 7.953. The mean is 72 point, we'll go 333. Okay, so if we want to calculate the z-scores for each student, we can just do it in the calculator, right? So stat calculators normal 7.9 72.333 is the mean. 7.953 is standard deviation. So if I want to calculate the z-score for student 1, I just enter them here. 76. I copy this. You can have another one open too, but 0, 1, and paste. And that gives me the z-score is 0.46. Okay. And you can just do all of them that way. Okay. So this is a lot for a video. I might go back and make a second video, so I might call this one part A. But yeah, I hope this helps you guys a little bit get off to a start on 3.4. So thanks.